Hello and a very warm welcome to everyone who has signed up for today's webinar. My name is John Norman and I am the moderator for this session. And today we will be presenting Translational Toxicology, focusing on data visualization across phases. So it's now time to hand over to our presenters, who today are from Optibrium, Aisling Cook, our Senior Software Engineer, and our CEO, Matt Siegel, who will host today's webinar. Matt, I will now hand things over to you.
Many thanks, John, for your introduction. It's a great pleasure to join you again today, and thanks to everyone in the audience. It's great to see so many familiar names and also many new people as well. So my duties here are really very simple. I'm very pleased to welcome Aisling to the webinar. Aisling is going to do all of the hard work today. Aisling is a senior software engineer here at Optibrium. She's been the driving force behind the work that she's going to describe as part of the eTRANSAFE consortium. And what you're going to see is the results of over 2.5 years' work and is an ongoing project working in collaboration with a wide range of FPA partners, small and medium enterprises, academic groups, and many others. So just before we get started, Aisling, before your main presentation, maybe you could just give us a little bit of background about the eTRANSAFE project.
Yep, so I'll go into a bit more detail about what the sort of core aims of the eTRANSAFE project are, but it's an EU consortium project which aims to investigate translational toxicology, and our role specifically is about developing a visualization application. So it really centers on the idea of how do you visualize toxicology data coming from a lot of different diverse sources so that it tells the user something interesting and might allow them to look at patterns. And as you said, it's ongoing, so it's a 5-year project and we're halfway through at the moment. However, for us, I guess, in the beginning there was quite a long phase of kind of requirements gathering and getting to understand toxicology data. So our real development work probably began about maybe 1.5-2 years ago now.
Thanks, Aisling. That's great. So without further ado, I'm going to hand over presenter duties to you. And you're going to tell us lots more about how you went about designing and implementing the new visualization software, and I believe also giving us a bit of a live demonstration of the current version. So over to you.
Yeah, so what I'm going to do over the next maybe 30-40 minutes is first I'll briefly tell you what eTRANSAFE is. Then I'll describe the kind of questions which were key in designing a visualization application for this project. Specifically talking a lot about end user requirements and then the potential data sources. Then I'll do a demo of the current version and I'll finish up with the challenges, the current work and the future directions. What is eTRANSAFE? So the eTRANSAFE project works to improve the efficiency of translational safety assessment approaches during the medicines discovery pipeline. That's kind of the official blurb from the eTRANSAFE website. What I'll aim to do is outline what this means in concrete terms for a visualization application that's trying to work within this larger project. So eTRANSAFE is an IMI project, so that's the Innovative Medicines Initiative, which is an EU initiative that aims to promote public-private partnerships with FPA partners, where FPA partners are essentially pharmaceutical companies. There are 27 partners in eTRANSAFE, and they are academic institutions, small and medium enterprises like us, and those pharmaceutical companies are FPA partners. And people are responsible for a really diverse range of projects. So different partners are responsible for things from text mining to sort of data donation to database building to modeling. And this, as I mentioned, is a 5-year project, and spring 2020 marked the halfway point. So we're 2.5 years into the project. So what is the aim overall? So the name comes from translational safety, and it's therefore not just about gathering toxicology data sources, though that is part of it, but it's about going further than keeping them in isolation in order to examine them in tandem. Preceding clinical studies with non-clinical studies is generally based on the idea that they are capable of predicting toxicity in people. But at a more fine-grained level, there are lots of questions. In what specific case is there good prediction, and when do they have poor predictive power? The software output of eTRANSAFE as a whole is intended to help toxicologists and chemists, etc., in the FPA and academic partners to understand translational toxicology and enabling them to investigate questions like, how predictive are animal models of specific adverse events? Is one predictive animal model more predictive of adverse event X than others? Or is this animal model particularly bad at predicting adverse events for this family of compounds? To that end, we define the goal of our visualization application as being to allow translational comparison between preclinical and clinical toxicology data, facilitating research and revealing interesting patterns. So this is a schematic showing the architecture of the whole system in the broadest possible way. On the left, you have a collection of diverse data sources which either provide toxicology data or some other kind of supporting data useful to users. These feed into the heart of the system, the hub, which is depicted in the middle. And this hub brings together these sources, but it is a stateless microservice system hosted in the cloud. And it shields the consumers from the diversity of the data sources, provides searching, and performs ontology mapping between the sources, something I'll return to later. Our visualization application is just one of several consumers, which are shown here on the right, providing a view onto the data. The information flow is unidirectional. Our consumer does not modify any of the data in the sources. In particular, our application is a desktop application, so users can install it on their own computers, whereas other consumers are web applications. So this beginning development, we knew the overall aim of eTRANSAFE, we knew where our application is supposed to sit, and that it is supposed to allow visualization of toxicology data, emphasizing translational aspects. How did we then come up with a concrete design to begin development? Well, a good place to start, if you're building something, is what end users wanted. But it's pretty hard for end users to be specific when nothing is there. It's much easier for them to have a concrete thing and then to say, but can it do this? However, some members of the consortium at the University of Vienna did an excellent exercise in requirements gathering. When they asked FPA partners, what research questions would you ultimately like this system to help you answer? And incredibly helpfully for us, many of the answers were expressed in terms of visualizations. So people were really already thinking in terms of visualizing. The other aspect which fed into and limited our initial design and planning was, okay, this system is going to have toxicology data, but what does that mean? What granularity is this data? What format? And these were not concrete answers when we had to start development. We knew that the sources were likely to be diverse, hence the kind of jumble of symbols, but also that some were probably going to remain unspecified for a while, hence the question marks, because there's this idea that new data sources should be able to be plugged into the hub, and if they're plugged into the hub, should we then provide visualization for them? There were three broad types of data that we had to think about. To be translational, eTRANSAFE needs some preclinical data and some clinical data. Further, there are these accompanying data that are regularly utilized by end users. The italic text in this table represents classes of data for which there was uncertainty about what this would actually entail when we began developing our application. So that might include, for example, whether even if such data exists in the hub, do we need to show it in our visualizations, and does it actually add value to the visualizations on our end? As you can see, this leaves only one thing which was certain about the data. This was that the preclinical studies would be in the SEND, Standard for Exchange of Non-Clinical Data format. So from December 2016, to bring some standardization, all submissions of preclinical safety data to the major regulators have had to be in SEND format. What does this mean? So for a single preclinical safety trial, you generate a set of tables called domains. Some of these tables describe the study protocol, like how many animals you used, the arms of the study, and others contain measurement data. In addition to this, The consortium also hopes to populate a study report domain, which is a new send-like domain proposed by a consortium member at Phil Drew from PDS Consultants. Why is this important and why is this relevant to visualizations? So send domains, the way that preclinical studies are transmitted, just contain raw data. They might, for example, report that 5 mice from the treatment group died throughout the study, but that doesn't tell you whether this was judged to be treatment-related. The original study report, which is a large text document, contains the expert review of the data by the toxicologist, and it's absolutely invaluable information. However, it's not currently contained within the SEND standard, which is why the eTRANSAFE project is aiming to populate this additional domain. It's also key to generating the visualizations that partners have actually asked for. So that's why it's critically important. Some of the kind of other unknowns from our point of view with the data specifically relate to clinical data. So clinical studies, what granularity would this clinical study data be at? This would influence what kind of useful visualizations we can make. The clinical study data could be at the same granularity as the preclinical, i.e., we could receive data into our application where we have data per patient within a study. For example, you might know exactly what patient X weighed on day 7 of the study. This is kind of advantageous because it has a direct equivalent to the preclinical data where we do know, for example, mouse Y weighed this much on study day 7. However, this is much more difficult for FPA partners to donate than sort of aggregated or summary clinical trial data, because at the moment, FPA partners are only required to provide summary information on clinical trials to public trial databases such as UDRCT. A different consideration and complication with the data relates to the post-marketing data. So what is post-marketing data? When a drug is on the market, adverse events which occur in people taking that drug are reported to various monitoring agencies. This mostly consists of spontaneous reports. So a patient kind of in the wild is taking this drug and has an adverse event. For example, a doctor could report to the FDA that a 45-year-old woman in Kansas was taking drug X and got heart palpitations, and that would be a spontaneous report. FAERS, CIDR, and MedWatch are all accessible sources of post-marketing data. The volume of data in these databases is huge, and while they have valuable information, we also want to make sure that in our visualizations, they don't swamp the kind of higher quality study data. Overall, the questions about data diversity can be distilled into one. How can you usefully, that is informatively, display toxicology data from such divergent sources together without a burden of transformation on the end user? So guided by the kind of shifting sands of the data and the thoughts of end users, we devised an initial design. We saw our role as being to produce a flexible and intuitive way to visualize both the system's data at a high level all the way down to looking at, single animals in a single study. We also, in line with the overall goal of the consortium, want to allow users to visually compare preclinical and clinical data. And to us, it seemed that we couldn't really do that without creating an application that allowed them to explore. The questions end users wanted to answer with visualization were broadly divisible into 2 levels. Summary level visualization, where the user wants to ask questions like, what's in my data sources? What species do I have data from? What drugs have data from many phases? Or are there any flags for sort of clusters of adverse events that suggest the need for a deeper look? This is the summary view, which is illustrated in mock-ups on the left, providing the user with an overview and the ability to simultaneously explore the data. The 2 example views, a sunburst and a PivotTable, have both now been implemented. The other level is for when the user has already identified an item that they are interested in, perhaps because of those flags, and they want to know in detail what is going on in that item. If it's a study, for example, they might want to plot what did this particular mouse, how did their food consumption, how did their body weight change over the course of the study, or how did the control group's average body weight change in comparison to the test group's average body weight. So the single study level, depicted on the right, allows users to dive into those details of measurements and the protocol. Specifically, this is a single study mock-up of a SendStudy. Being the best defined, that is the first single study view under development, and this is what I am currently actively working on. We began development with this summary view, and the first and quite large task was to understand what information is necessary to extract from the hub in order to build a useful summary view. We knew several things about it. Firstly, it should satisfactorily represent information in the known data sources, but also be extensible if new ones are added. For the translational aspect, some underlying concepts of the data must be shared across phases such that we can eventually visualize them together. And finally, we know we definitely don't want to pull back absolutely every bit of information about everything in the hub in order to build such a summary view, as the amount of data involved would be absolutely enormous. Instead, you want key pieces of information about each item. We therefore began to consider the data as being composed of three fundamental types: drugs, reports, and adverse events, which are related hierarchically as shown in this schematic. Here in this example, you can see we just have these two drugs, and each of those has some variables associated with them. A drug has a SMILES, which describes its structure, or an INCHI key for the same purpose, or an identifier. Each drug then has one or more reports associated with it, and these two are defined by some variables. So you can have a species in which a study or report was conducted, you can have the phase it belongs to, and finally, each of those reports has 0 or more adverse events associated with it. And these also have variables that define them. For example, the severity of the adverse event, or the tissue. Where did the adverse event occur? So I know that in different areas of toxicology, people use the terms adverse event or finding differently. However, within our program, where we want to look at things in a cross-phase way, we just needed to pick a term that means a bad thing occurred that may or may not be causally related to the drug. So we settled on adverse event. We're considering the report as the fundamental unit of all of the data. But what exactly is it? So for the study data, it's pretty simple. A single study, a single preclinical study or a clinical study is a single report. But for other sources of toxicology data, there might not be such a direct equivalent. So consider again that post-marketing data. We definitely don't want to say one spontaneous report is one report within my scheme, because FAIRS contains 15 million reports. So instead, a report should be something that usefully aggregates or bundles your adverse events. For example, you could take the data from FAIRS and bundle it according to the drug to which it relates. So based on these three types, we then worked with other partners to devise a prototype summary data format, which could be feasibly extracted from data sources and would contain variables shared in a meaningful way. And this then fed into and influenced the way that summary data can be extracted from the hub now. What became immediately apparent was the essential role of the ontology mapping group. So this is a work package in eTRANSAFE, which is responsible for mapping the ontologies that exist in the different domains. Now, this is a massively complex subject, but for my purposes, what is an ontology? An ontology can be simply defined as a set of preferred terms used within this world. The most crucial mapping for visualization in this project is between the preclinical and clinical ontologies. And I will show an example of why. So consider the case where you have one drug and you have a preclinical study for it and a clinical study. And each of these have some adverse events. So this preclinical study might be working in the world of SEND. So it'll have terminology for the location of an adverse event. And this is at quite a fine granularity in SEND. So it might report that it occurred in the submandibular lymph node. The clinical study might be working with the MEDRA terminology. And an adverse event which actually relates to the same location might be reported with the system organ class of immune system disorders. To create a useful visualization automatically or easily from these data, there needs to be something known that a relationship exists between these so that it can be highlighted to the user. Our application is not responsible for this within eTRANSAFE. This incredibly clever work is being done within the hub itself, such that data pulled from the hub by our consumer will already be mapped. So I will now do kind of a brief demonstration of our current version of the application, which is a development rather than release version, so it's quite stressful. The application has the working name Sirona, and it'll just be kind of a quick breeze through some of the features which you can use. This is what you see when you load some data into the current version. So firstly, the data here is synthetic. They're kind of randomly generated, so don't try to analyze the data, but instead, I guess, evaluate the functionality. So in the center, we have the summary table, which displays these summary data. So this high-level picture I've been talking about all of the different toxicology data coming in from different sources. We decided that the pivot table design, which was originally considered for delving into a single study, would also be useful here. But before I get into any of that sort of more complicated pivot table behavior, what do these cells contain? So these cells in the body of the table contain the counts of the number of drugs, reports, or adverse events, reflecting again those underlying types I described. The default is the report count, you see here. But it's easy to just change what the cells contain. They can contain one or more, but at the moment I'll say I would like my cell counts to be in adverse events. To pick an example of a cell, so what this cell is saying is that for my fake drug A, in hamster, there were 5 adverse events reported in the adrenal gland. But if that table configuration is not really informing you of anything, I'll return to how you can reconfigure it pretty much kind of in any way which you would like. These 3 symbols and these 3 colors, so gray for the compound, sort of blue for the report, and this saffron color for the adverse event, are a motif which recur throughout the application. For example, you can also see them in the headers. So here I have organ and drug identifier on the y-axis. An organ is in saffron because it relates to an adverse event. It's a variable for an adverse event. Where did it occur? In contrast, the drug identifier is in gray because it's a variable that relates to the drug. What's the drug identifier? These are intended to remind users always that as they work in this world of summary data, these data belong to 3 underlying types. But back to the sort of functionality of the pivot table. Why did we think that a pivot table and our other core summary view, which is the sunburst, were a good way to provide an overview of a lot of toxicology data? Well, we wanted to provide interactive ways to arrange hierarchies of variables. Our thoughts were that a user won't just want to know what percentage of their study were in rats, but also, of those in rats, what percentage were in Wistar strain, and of those that are in Wistar, what percentage were repeat dose toxicity, and so on. The functionality of the pivot table allows this. You can add, remove, rearrange available variables to modify the view onto the data. Removing variables aggregates it. And it's a bit abstract, so hopefully I can kind of make it a bit clearer with an example. So you open up the configure table dialog, and this is where you're allowed to modify the variables. At the top, it's showing your initial state. So this is that I have phase and species on the x-axis, organ and drug identifier on the y. Clear. At the bottom, you have the available but unused variables. And again, we see that color motif. It's dividing them up into variables associated with the different levels. The simplest possible table is basically just a list. It's just saying, okay, well, show me what values exist for that variable. So the variable is severity, and it's like, these are all the different values that exist in my data. This is kind of, it's not particularly interesting, but you can view it in different ways. For example, you can switch to the sunburst view. This is an alternate view onto the same data. We'll return to this later. So you can build more interesting tables. Potentially you are a modeler and you want to look into modeling translational toxicology. A table that might be of more interest to you is to ask, of the data here, are there any drugs which have data, toxicology data from a lot of species? So I put species on the x-axis, smiles on the y, and build my table. You can see that we get the drug structures, although you can turn them off if you would rather the raw smile string. You can also see, I guess, that some drugs do have data from maybe 3 or 4 species, and you can identify those. And it's also apparent that in this data set, hamster and human contribute the bulk of the data. Now, there's not a limit to the number of to the number of variables that you can place on the different axes. And you can also, as I think I've kind of already demonstrated, you can mix variables from different levels. So you can mix an adverse event variable with the drug, etc., etc. So here I'll just build one final table before moving on, where I'll put phase, followed by the smiles, followed by the species. And now we're getting into something a bit more complex. Another thing that might be apparent is that the table also functions as a heat map. In the default, the more orange a cell is, this indicates there are more adverse events in there. However, you can sort of configure this quite a bit. You can, for example, change the range, you can modify the color, etc. This is sort of the core view where you can have a table or a sunburst. But there's also the plots dashboard or charts dashboard. This provides yet more ways to create visualizations of the same data. And again, we're working in that world where anything can be considered in terms of being a drug, in terms of looking at the adverse events or the reports. And you can do quite a lot of customization. For example, here I'm building a histogram where the height of the bars is showing you what proportion of the adverse events here come from the clinical versus the preclinical. And I've now sort of colored by the species. And this plot dashboard allows you to add like a lot of charts. You can add, remove, rearrange them relative to each other, etc. At the moment, the other chart type is the pie chart. And again, I will just do a random example, which is such a pie chart shows you who contributed the data within this data set. So I mentioned in the beginning that we wanted to build a summary view which allows users to explore, but I haven't yet to do any exploring. So we would like to allow users to focus in on subsets of the data. And some of the motivation for that is because at this very high level, although this is only about 10,000 adverse events, when often data sets we're working at will have tens of thousands of adverse events. But some of those high levels, some variables are not so relevant. So for example, if I made a pie chart with the variable organ showing where did this adverse event occur, it would have so many values, it would be essentially unreadable. But when you get down to a subset, it becomes much more informative. So the first thing which I will do in order to focus is I will rearrange the table again, and I'll lock my pie chart. I'm locking my pie chart because although it's really easy for users to save or copy out charts, they might want to lock a chart in the current state, leave it in here, so that as I move through super and subsets of the data, this chart is not updating dynamically because my other ones will by default. The way in which you focus on data is by interacting with the headers of the table. So this is essentially building a Boolean filter, which is saying, I'm only interested in data which occurs in, or which is from hamsters or humans and has adverse events which were recorded as finding equals abscesses. Then I click the focus button. What's updated? First thing is that my focus panel, which shows a linear history of how you move through the data, shows a new entry. I used to be at the level of all data, so about 10,000 adverse events, and now I'm down to 46. My table is updated, my histogram is updated, but my pie chart hasn't. And now maybe you want to just, again, explore down here. So you can swap to the sunburst view, which, because I have many fewer values, now looks quite different. And here again, you can configure this in a really similar way to the table. So again, we have those available variables, and I can build one with 2 rings, species as the outer ring, whether an adverse event was treatment related as an inner ring. And it looks like this, and you can also, for example, just customize. It's much the same functionality as the table. And finally, you can also drive focusing. The user might again say, well, no, I'm actually only interested in data which was judged to be treatment-related true. And you again focus down. The focus panel doesn't just contain kind of a static history of where you've been in your supersets. It also allows you to hop back up to a previous level. So I decide, okay, I've filtered or focused to treatment-related true, but I actually want to hop back up. I just press this, and it jumps back up to that level. That kind of concludes, I guess, quite a whistle-stop tour of the current functionality, which is really a work in progress that sort of has so many more features to add. And I'll just describe in my last few minutes what the challenges have been thus far, and also what our upcoming features are and what users should be able to do soon. So in terms of challenges, I'll keep this quite brief. This is a very large and complex project, eTRANSAFE as a whole, I mean. And you have a lot of different partners building different components of the same software system, which is just inherently complicated. Furthermore, we're building a client, so we're building a consumer. We sit on the end of this big, massive system, but we still have to start developing from sort of day one, which was quite a challenge. I've already discussed the data complexity and diversity quite extensively, but I think another interesting challenge which relates to that is the idea of whether you should build a piece of software which is very flexible and extensible or specialized. If you build something which is super flexible, this would essentially mean that it would cope superbly well with any new toxicology data sources that are added to the hub. However, at its extreme case, it would just be a general purpose plotting application, which is useful, but it also means that the end user has to do a lot of transformation in order to create the plot they want. At the other end, you have something very specialized, which might hinder the addition of new data sources. Obviously, we hope we've done something a bit in the middle, but I would say it leans a bit towards specialized. So what are we doing at the moment, and what are we doing next? So as I discussed previously, the preclinical safety studies are now usually within the SEND format. And our next task, which I'm already embarking upon, is building a view which uses the PivotTable paradigm in order to kind of really allow users to delve into that measurement and protocol data of a SEND study. And I'll wrap up with just some a little kind of a sneak preview of what that is. But there are so many things that can be improved at the summary level. Firstly, we'd like to add more chart types. Some of those are already known. So for example, we've always known it would be very useful to add a chemical space plot at that summary level so you can see your drugs which are in this data set in a chemical space. But until recently, exactly what information would be contained within this summary data was still not fully concrete. It wasn't fully solidified. Whereas now we have a very good idea of that. This opens up new avenues for kind of exploring or thinking about novel or specialized visualizations at the summary level, which really work with the information available from this system. And in a similar way, we also know what variables will be available. For example, the frequency. So that is, what was the frequency of this adverse event? What proportion of the animals in the study experienced it? And with such variables, we can build and make the view we have already much more complex. So at the moment, the pivot table, it's just adding raw counts, which is quite a naive approach. And it could be vastly improved by looking at frequencies and the different ways in which you could combine or aggregate frequencies. Finally, we also have to consider the idea that as new data sources are added to the hub, we may need to think about, is this valuable to be incorporated into the visualization application? And we always need to think about which additions add the most value to the visualizations that exist. So as I mentioned, the tail end of it, the last couple of slides, will just be about this SendStudy View and what this may be able to bring into visualizing SEND studies in a flexible way. So I don't expect anyone to even look at or inspect these sort of spreadsheets. What this is doing is just showing an example of what SendStudy looks like when you open up the domains in Excel. And this comes from this GitHub address. So as I said, this is the format which is mandated by the major regulators for preclinical safety data. It consists of a set of tables. Some are protocols, some are measurements. This is great progress in standardizing the data from preclinical toxicology trials, But it's not really very simple as a human to browse the tables directly. And even if you come with questions such as, oh, well, I'd like to look at whether there was, you know, a difference in the average liver weight per sex group or per dose group, it's necessary to go to multiple different domains to link up that animal ID, which would be in a demographic domain, to the sex of that animal, to the actual measurement, which will be in sort of the measurement domain that relates to that. We're in the very early stages of applying the same pivot table paradigm that I showed you to the SendStudy, and we're hoping it'll provide the same flexibility and intuitive approach. So please excuse these. These are screenshots from a demo program. What I mean by that, it's a piece of application which is kind of a sandbox to play around with the fundamental ideas that we're going to implement, and then we throw it away and do the real thing. So what you're looking at is a single send domain, the MI domain. This contains toxicology data, measurement data, derived from microscopy of cells. At the summary level, the variables for the pivot table were things like species or phase, but here it is the independent variables within a study, like study day, animal ID, or dose group, which you can see on these axes. The MI domain is a categorical domain. What do I mean by that? I mean that a single data point is either normal, the keyword normal, or it's some abnormal result described by a string. We can therefore aggregate this by displaying what proportion was abnormal, for example. So in the demo, I just go into my configuration dialog, remove the animal ID, and get this table. So now we're beginning to group the results. I've removed animal ID and it aggregates, and now it's showing, well, what proportion had something abnormal. And again, just the demo is intended to show you can apply the same kind of heat map logic in order to highlight hotspots that might be of interest. Some domains of the send contain numerical data, such as organ weight in grams or clinical chemistry measurements like albumin concentration. Here we're looking at an example of a numerical domain, so this is the body weight domain. Again, we have those independent variables, and you can see that the measurements are taken for each animal on repeated days, so their body weight is recorded repeatedly. If we remove sex and animal ID as variables, you again get this aggregation and a different view onto the same data. So this is the resulting table, where you have a column for the control and a column for test, and this is really simple for the user to do. In the full program, this will be accompanied by a charts dashboard, and you can sort of imagine that there are many charts that lend itself well to such a case, like a multi-line plot with study day on the x-axis and body weight on the y-axis, etc. So once the single study view is completed, users using this application will be able to view data from ToxHub at kind of two fundamental levels. Firstly, one of high N, where there's thousands of studies and very low granularity. And then the one where N equals 1. They're looking at one study with the highest possible level of granularity. They're looking at all the information. It's then kind of a natural progression for users to ask to look at something in the middle, i.e. they might say, well, I would like to look at just a handful of studies at the highest possible granularity, and I want to visualize them together. The most sort of pertinent case for eTRANSAFE is, of course, I have drug X, and I have a clinical trial for it, and I have a preclinical trial. I'd like to see all of the data from those studies together, and that is kind of an avenue which will open up once the single study view is completed. But there are so many interesting questions in that area. For example, you know, when is it valid to throw that data in together, and when is it invalid? So as Matt and I have already mentioned, this is very much a work in progress, but this is sort of what we have done thus far in terms of visualizing this toxicology data and really thinking about the idea of combining toxicology data from divergent sources. That is me.
Thanks for a great presentation and a really interesting demo of the Sirona system that you're developing. We're just approaching the sort of Q&A session. I can already see that several questions have come in, but I can also see that other people are busy typing away. Just to give a few minutes for people to submit their questions, maybe you could just tell us about you know, what's the status of this project and what's the plan from here?
Yeah, so I think I've said it a bunch of times, we're about halfway, and in terms of the next big project and the thing that we're already kind of getting stuck into is this idea of like quite a complex send viewer. So really allowing users to explore that data in detail. There are some other things which are kind of also ongoing simultaneously. So integration with the hub, in particular kind of getting a good user experience for users by allowing them to switch between and transfer data between our visualization application and other consumer applications in eTRANSAFE, so in particular a web app. So that's kind of an ongoing project as well. Sort of upcoming concerns are also the idea of really pushing it to its kind of performance limits as we get access to more and more data, and understanding what we have to do to give users a really good experience in terms of performance, because the whole idea is that the system is bringing together a lot of data, therefore the visualization on our end needs to be able to cope with a lot of data.
That's great.
Yeah, I think that's...
No, that sounds like a really exciting set of developments to come. So yeah, we've got questions flowing in, so maybe we'll get started. The first is just to note, you've obviously shown us a great demo of sort of visualization of the sort of summary level information, and talked a bit about applying similar sort of approaches to send information. But are you planning to have an equivalent way to view other types of data? You mentioned things like post-marketing and clinical information.
Yeah, so the long-term plan would be to allow users to also dive into different types of studies. So soon, hopefully, they'll be able to get down to the level of a single preclinical study and go, yes, show me all of this. Naturally, we would like that for as many different types as possible. But there's sort of several aspects. So for things like post-marketing, there really isn't that much more to dive into. What you see at the post-marketing, or sorry, at the summary level for the post-marketing really contains a lot of the information. So probably wouldn't be building a really complex view allowing you to dive into that. Then in terms of the clinical, we definitely do want some kind of equivalent view to dive into a clinical study. But that is still sort of dependent on what becomes the main granularity or format of clinical data within the system. Because as I said, if we are able to extract single patient clinical data from the hub, then it's really easy to think of an equivalent view to the send view, where you just sort of drop in the clinical data, which would probably be SDTM sort of form if it was per patient. But if, for example, the major type of clinical data we end up extracting from the hub is already a bit aggregated, then we'd need to think about how applicable would the sort of paradigms that we're using for send, how would they work? And I think it's kind of a rolling process, and doing the single study send viewer will lay a lot of groundwork for that as well.
Fantastic. Thank you very much. Alrighty, so next on the list, tox responses are directly linked to drug exposure, which can vary significantly across species for a given dose. Are exposure data captured in the database? And if so, how are they captured in visualizations to help to normalize response to exposure, especially when making comparisons across species for translational analysis?
So I can't speak to all the data sources, but I know there is pharmacokinetic data within SEND. And if it is within the SEND, then we will extract it and we will display it. But I think this person raises an interesting point, which is actually something I've been already thinking about, and also talking with some people from Certara who are also involved in eTRANSAFE, in terms of what special visualizations do you want in order to display that sort of data, and will it be covered by the types of visualizations we're already planning, like, you know, box plot, multi-line, or do we really need to think about that in a bit of a different way? In terms of the other databases, it's definitely not present in the post-marketing. And again, for what becomes the major clinical trial database, I'm not entirely sure yet. So I think that, yeah, for SEND, we definitely want to utilize that information in the best way if it is present.
Great, thank you very much. Okay, number 2 on the list. What are the data sources for these data sets? Do they come from the pharmaceutical company itself? For instance, if a data set was bought from an external source, how might it be added into the system? For example, would it be through Excel or another format or another mechanism entirely?
So this is being built as part of this large eTRANSAFE project. So at the moment, all of the data and all of the data living in the eTRANSAFE project and eTRANSAFE hub is donations from pharma companies and from those pharma companies which are members of the consortium. Therefore, the data which we're going to be working with at the moment in the lifetime of this project is what's extracted from there. We're mostly at the moment focused on really just, using our application or allowing users to use our application in connection with this hub, this eTRANSAFE hub. So we're mostly focused on, just that connection. However, you can kind of see how it would also be possible to adapt our application such that you could read in single SendStudies from your local machine if you had them. But at the moment, the real focus is on this as a way to visualize the contents of this eTRANSAFE hub.
Thanks a lot. So I guess the next question is somewhat related to this, which is when it's ready for release, will this module be accessible to consortium members only or more widely accessible?
So yes, it's quite connected in that. Really, the core focus is on allowing people to exploit the hub, and therefore our kind of primary focus is those people that are members of eTRANSAFE. In terms of other people, the hub provides a lot of complex behavior in pulling together that summary data. So it provides searching, but also does the ontology mapping, etc., which is a really, really complex thing. It's not simple to say how our application would work in the absence of the hub at the summary level, but yes, single study or single item viewers, it's much more easy to envisage how you could use this without the hub as the source.
Thanks, Ashing. I think it's also worth mentioning that obviously the focus of this project is development of the software as guided by the consortium members, and of course they will have access to the software at the end. But I know that there is sort of a longer-term vision to make the platform available to others who are not original members of the consortium. So I think the access will be much broader following termination or following the end of the project. So yeah, there will definitely be mechanisms to access the software for other pharma and biotech companies. Okay, so let's see. This next question is related more to, if I understand it correctly, the sort of send type data. So once you standardize the data, is there a translation table so users can see how the units they're familiar with are translated to your tables so they can distinguish events that are interpreted as bad from those they think of as good?
So I guess in terms of the translation table, we wouldn't store anything like that or something equivalent on our end in our local application, or that would not be the plan for now. The reason for that is sort of there's a lot of work going into even stuff like unit standardization within the hub. So we just sort of take our information from there and don't want to encode any kind of like brittle relationships locally on our side, as they're just liable to break and liable to not move with what the consortium as a whole decides it wants. Because of that, people might not always end up with the exact units that they want. But I think it's better than trying to implement sort of translation on our side is a bit of a sort of a slippery slope, in my opinion, I would say.
Great, thank you very much. So this is more a philosophical question, I think. There are already a number of powerful data visualization tools around. Why have you, and I guess you is a very broad term in terms of the consortium, decided to build from scratch rather than configuring existing software to appropriately visualize the hub data?
So it's a pretty good question, but So one thing is that I didn't build this fully from scratch because I work for Optibrium. Optibrium's core software is a piece of software called StarDrop, which is used in early stage drug development, and that has a lot of plotting and visualization capabilities. And that provides sort of what we call a core plotting library. So it gives you a bunch of functionality related to plots for free. So it wasn't fully from scratch. But I guess in terms of the advantage of trying to build something which is very tailored to the eTRANSAFE project rather than just something using a tool which already exists and is flexible, it kind of returns to something I was saying in the challenges, which is if you are a power user, you probably want something that's like just allows you to do absolutely any combination of anything, and you are willing and able to set up the different configurations to transform your data to make sure things are transformed into the appropriate places. But I guess we were pitching this not so much at the power user. So we wanted to take that burden of transforming things off the user and tailor it to the hub so that they don't have to do that. But yeah, I mean, I guess that is a very valid debate.
Yeah, I mean, I think it comes down to the specialization of the data, but also the very complex structure of that data, but also the specific questions one wants to ask of it, and being able to develop something that is really tailored to those questions and to the particular structure of the data. You end up with a much more intuitive tool to really get to those answers very quickly. I think that's just what you said, Aisling, so apologies for repeating. All right, another great question. You mentioned SMILES, and I guess particularly small molecules, but are biologics supported in the hub and Sirona?
So this is actually the reason why I sort of volunteered and really was interested in this project was I was very interested in the representation of larger drugs and sort of things like Helm notation, etc. At the moment, sort of that's something we're always bearing in mind because biologics are big, but we will always move with what the hub is doing, at least for the duration of the project. So when the other facilities of the hub begin really supporting biologics in earnest, then of course we need to allow users to exploit that appropriately on this front end. But I would say at the moment sort of biologics are a little bit on the back burner, but always watching what we need to do with that, I would say.
Yeah, but clearly biologics are a very important area both now and increasingly in the future. So I think it's always been envisaged that this would be extended to cover biologics. I think it's right to say at the moment that the vast majority of the data are for small molecules. So that's clearly the initial focus. Okay, and I'm just aware of the time creeping up on us. So I'm just going to go for one more question before we wrap up at the end. And this one is relating to something you mentioned before in our StarDrop software. Would any of the visualizations or pivot tables developed be included in StarDrop in the future?
So one thing that I know is potentially more directly translatable into StarDrop is any new plot types that are developed in the eTRANSAFE. So for example, at the Sunburst, there are some plans afoot to do a 3D surface plot. I have no knowledge of whether these will be sort of incorporated into StarDrop and what applicability they would have in there. But I guess once we write them for eTRANSAFE, it would become easier to incorporate them into StarDrop. I don't know whether they would have appropriate or like worthwhile use cases. And the pivot table I think would be a bit more complex, but maybe that's more of a question for you, Matt, I would say.
Yeah, well past that buck there, Aisling. So yes, I mean, clearly, our focus in this project is making sure we develop the best possible visualizations, the best possible ways to work with this very complex translational safety data. But many elements of this technology are clearly dual use. Aisling provided some good examples of visualizations, but we also know that we deal with hierarchical data in drug discovery, multiple replicates of the same experiment where we aggregate at different levels, for example, aggregate between lots or batches of compounds as well. So clearly, yeah, there's lots of opportunities to take these methods and this technology and move that into StarDrop as well, very much so. So it just remains for me, first of all, to say a big thank you to Aisling for a great presentation and demo and for answering so many questions. A big thank you to all for joining us today. And if you do have any further questions that we haven't addressed today in the webinar, you're very welcome to contact us at info@optibrium.com, and we'll be very happy to answer your questions. So thank you very much, and I hope you have a good sort of morning, afternoon, or evening, depending on where you are in the world. Bye-bye.